The solids are a new class of solids first, and with a lot of new properties starting from environment to health and to energy too. Because the solids are porous solids, that means at the atomic scale, I created cages in the solid in which I put other molecules. And these molecules can be CO2, hydrogen, methane, for instance, for environment, and can put metals, and it's very interesting for catalysis and energy savings. And more recently, I can introduce in these cages drugs. Drugs against AIDS, against cancer, against diabetes. And what is interesting in this case is that not only they are absorbed, but they are delivered, and not in one day, but in 3 weeks. That means that if you think about the patients in the hospitals, instead of having an injection every day, it's every 3 weeks. So all these results are patented now, and probably you will ask me when will it be developed. It's on the way. For instance, for health, we are beginning trials on humans next year. It's on rats, it's okay. Rats are in good shape, I'm sorry. But in humans, in 1 year. So here are the solids on which I work. The product exists. The material exists, and the shaping of the material exists. So that means that if the companies are decided to produce it at large scale, the solids, it will work. But it's not my decision. It's the decision of companies with financial, besides scientific problems, and but it's possible. I have already contacts with some European companies about that. I know that management discusses about the development of the solids, and mainly for adsorption and CO2 adsorption. But for me, even if I'm happy with the discovery, the adsorption and the sequestration of CO2 is not the final solution. We have found the solution to trap CO2, which helps. But after the trapping, in large scale, what will we do with this trapped CO2? You know, I have a good friend of mine in France, who is a former Minister of Research and who is really an outstanding geologist. And as you know, there are ideas to store CO2 in caverns and so on. He agrees with this solution, but it says to me, take care, because we don't know at the long term the reaction between CO2 and the rocks. So they are working a lot about that. They are optimistic. I can say that they are optimistic. But as I said to you, it's just a step. The final is to destroy CO2, which is rather difficult because CO2 is a very strong molecule with strong bonds, and so it's very difficult to cut the bonds. But the solution exists. We are working on that. We have solutions. But what I can say is just that the yield of the reaction is not enough for me for large applications. But what is interesting is that we transform this poison in water, which is not a poison, and methanol or methane, which can be used for energy. So This is the state of the art for the moment.